William Douros, West Coast Regional Director for NOAA's Office of National Marine Sanctuaries, will discuss how sanctuaries are addressing the potential threats and challenges for global climate change. Thank you. Important. Thanks, everyone. Climate change, which is linked to warming ocean temperatures, ocean acidification, sea level rise, weather patterns, could cause fundamental changes to marine and coastal ecosystems. The Channel Islands, one of the most diverse and abundant marine environments on the planet, provides a natural venue for researchers to study these impacts. So please help me welcome Regional Director William Douros.
Thank you, Bill, and thanks for the opportunity to come here and give you all a presentation. This is the screensaver on my computer, so forgive me, I got to get that back up. This is from a vacation in Italy, so this was not necessarily part of it. I know it. I had to jump up just in time because you never knew what was coming next. Well, I know, but you don't. Again, I appreciate the chance to come here. The Office of National Marine Sanctuaries has been working on this issue, not that long, only for the last, 18 months, I'd say. And I've been impressed with what National Park Service has done. They've been working this issue probably for 3 years, 4 years. And so for me, it's sort of a special treat to come and speak to you all here at a Park Service Visitor Center. This series that the Sanctuary Program puts on, the Park Service puts on, I think is a really cool thing that you all have been doing for 6 years, 7 years now. So I'm going to talk about climate change and what it has meant to us in this program as we've really started to dig into it in the Sanctuary Program. But I thought I'd also give you, a quick tour of national marine sanctuaries on the West Coast. We aren't as numerous as a region in the National Park Service. They might have 40 units in a region. We've got 5 on the West Coast, but they're pretty big areas. There's an awful lot going on in them, and so I know all of you are probably rock solid familiar with Channel Islands National Park and National Marine Sanctuary, so I'll give you a little bit more on some of the other ones. And then I want to talk about broadly what is climate change, what does it mean broadly, and start to narrow it down, what we've been doing about the issue and about the problem to get a better handle of what the problem is, and ideally, of course, to get a sense of what are some of the solutions and mitigations and adaptations that are necessary. So let's see if this moves forward. This is the National Marine Sanctuary System here on the West Coast. There are 5 sanctuaries, and I'll give you a little bit more information on each. Olympic Coast, and I will point out it is adjacent to Olympic National Park. Most of the shore, not all of it, most of the shore is protected by Olympic National Park. Cordell Bank Sanctuary down in California is off Point Reyes. Gulf of the Farallones Sanctuary protects the waters around the Gulf of the Farallones Islands, and I'll point out it is adjacent to Golden Gate National Recreation Area and Point Reyes National Seashore. Monterey Bay Sanctuary begins off the Marin Headlands and extends down about 300 miles, including a new area that was added offshore, and then the Channel Islands National Marine Sanctuary down here. This gives you some numbers. We didn't update this slide for FY10, but the budget numbers are about the same. About $9.5 million for all the sites on the West Coast. I think Channel Islands National Park budget's probably $9.5 million. These are, in some cases, small staff, 7 people at the Cordell Bank Sanctuary, 31 at Monterey Bay, and you can see here some statistics on the size of these: 3,000 square miles, 529, 1,200 for Farallones, over 6,000 square miles for Monterey Bay, and then 1,400 for Channel Islands. So to give you some, more specifics on this, here's the Olympic Coast Sanctuary, and an important thing in terms of the resources that are protected by this sanctuary includes shoreline areas, some pretty dramatic coastline habitat, some invertebrate species that are in these tide pools, like this aggregation of Piesaster. It's also an area with some huge seabird colonies There's some national wildlife refuges along the coast that protect some of the seabird colonies. This is a colony of common murre. But the Native Americans that are in this area are a really important part of how we go about our management of this system. There are 4 Native American tribes that have tribal treaty rights, access to the marine resources offshore in the sanctuary that were part of what they agreed to when they reached treaty agreements with the Europeans. And that includes the Makah in the north, then the Quileute, the Quinault, and the Hoh along the coast of Olympic Coast. And we work very closely with these tribes, in some ways even closer than how the park here in this Channel Island Sanctuary works with the Chumash. For Cordell Bank National Marine Sanctuary, again, this is about 500 square miles. It's 6 miles offshore. It begins, and it includes this large bank feature, as well as some escarpment and canyons that are a part of the continental shelf that's torn away here. Definitely some continental shelf and slope area here. For reference, here's San Francisco and there's Point Reyes. This was the second sanctuary designated on the west coast. Channel Islands was the first one. You can see there are some huge rockfish aggregations on some of the rocky features, and the rocky areas are predominantly on the bank itself and some of the canyon areas. But there's still some amazing features with these invertebrates that are on the bank. And they attract, because of the upwelling that occurs in this area, very dense aggregations of different seabirds. This is an albatross. They fly over from Hawaii and are very commonly found this time of year at the Farallon Islands, as well as and Cordell Bank, as well as Monterey Bay Sanctuary, and occasionally here as well too, where they come and they feed on krill and squid and then fly back to Hawaiian Island, the Hawaiian Islands. There's also real important aggregations of blue whales, humpback and fin whales, and a number of other marine mammal species at Cordell Bank Sanctuary.
How shallow do the banks get?
So the top of that is about 120 feet of water, the very top of it. So that's the shallowest point. It gets considerably deeper, down to about 3,000 feet in this area here. And at one time it was exposed. I mean, it was an island, 10,000 years ago. So adjacent to it, and it's an interesting part about these sanctuaries, we got 3 continuous sanctuaries here, but in the center is Gulf of the Farallones. The centerpiece is the Farallon Islands, but the Gulf itself is an important feature for this area, as well as then the escarpment itself. And as I mentioned, the Point Reyes National Seashore is in this area, and the Golden Gate National Recreation Area includes part of this and part of the area off San Francisco. The islands are a really important feature. There are 2 main islands there, the Southeast Farallones and the main Farallon Islands. There are some wetlands, 5 wetlands, estuaries that are part of the sanctuary itself along the mainland, up off the Marin coastline, including the biggest, which is Tomales Bay. Seabirds and shorebirds are very common in this area. It's the largest seabird breeding colony in the lower 48 states, is at the Farallon Islands. It's also an aggregation point for pinnipeds. These are young elephant seals, and they attract white sharks. And this is, the place to go in some ways to see white sharks in the United States. A very important part, in my mind, of the natural history of this. I'll give you just a second on this. There are 3 main populations of white sharks in the world: off South Africa, off Australia and New Zealand, but mostly off Australia, and then here off the Farallon Islands and Guadalupe Island, down off Mexico. That's where you find the big adults that come in. They come in for the pinnipeds predominantly. And an important part of the story, and we're starting to dig into this more, is what's going on at the Channel Islands. I know you just had recently a shark attack, or a sea lion that had been bit by likely a white shark. And we want to get a better handle on what's going on, because if you think these are 2 island populations to the north and south of the Channel Islands, but by far the population of pinnipeds at San Miguel dwarfs what you find at Farallones and what you find in Guadalupe. And the only thing that seems to be agreed upon right now is that the female white sharks who disappear out into the Pacific, when they come back to pup, they make a beeline from Hawaii and the Pacific waters for the Channel Islands and the Ventura coastline. And this is where the Monterey Bay Aquarium, who's been tagging and searching for juvenile white sharks, this is where they come to catch the white sharks that go into their aquarium, is the Ventura Malibu coastline. So we know the females come to pup to this area. We don't know, do they hang around at all? San Miguel is quite a ways away, although Guadalupe is quite a ways away from shore. Farallon Islands is easier to do science at. It may be a whole different hunting regime there. It's a sandy bottom where it's rocky at Guadalupe and at the Farallon Islands. But over the next couple of years, we're going to try to start doing some tagging, budget permitting too, as well as some monitoring of other sharks that have been acoustically tagged to find out, is there really nothing or very little going on out at San Miguel, in particular in the Farallon and the Channel Islands, or are they the females just coming here pupping and then heading up to the Farallon Islands? So anyway, it's a really important part. I thought I'd flag that because you just recently had a shark attack, and I know people here are worried about that. So for Monterey Bay Sanctuary, this is the largest national marine sanctuary itself. As I said, it's 6,000 square miles of coast, and we recently added this feature, the Davidson Seamount, to it, an old volcano. But it includes coastline, and a lot of this is populated or privately held coastal areas. As I mentioned, these other sanctuaries on the West Coast have quite a bit of public holdings along the shore. The deep Monterey Canyon attracts a lot of things like jellyfish. Those in turn attract other predators, if you will. Leatherback sea turtles are common in this area, but also other pinnipeds, dolphins, whales are pretty common in this area. There's 33 species of marine mammals, and I know there's an avid whale watching community here, but it may break your heart to know that Monterey Bay is an even easier and better place to go see whales. It's 3 hours. There's a total whale watch trip. Within 40 minutes, you're seeing blue whales. I know, to go here, you can see blue whales pretty regularly too, but it can be a little bit of a rougher haul for some of the trips in this area. So anyway, we are blessed in the sanctuary program with some of the best whale watching in the world here on the West Coast with Farallones, Monterey Bay, and Channel Islands. As I mentioned, the Davidson Seamount was recently added. The top of this probably has never seen daylight. The top of it's in 4,000 feet of water. The flanks of this seamount extend down around 7,500 feet. And so the base of the seafloor here for the seamount is in 12,000 feet of water. So you can imagine a volcano that extends up almost 8,000 feet. It dominates the oceanographic landscape the way Mount Shasta dominates Northern California. For those that have been in Northern California, you can hardly turn around without seeing Mount Shasta. It rises up about 8,000 feet. That's the same effect that this seamount has on the seafloor, and it's covered with corals and sponges. This is called a flytrap anemone, and it functions just like a Venus flytrap when organisms get inside it. And we've, as I said, added that to the sanctuary. It's a really important feature. And of course, this coastal area in particular, you walk out of your home across the beach and you're in the sanctuary. So then the Channel Island Sanctuary, I certainly won't dwell on this. You all know this as well or better than I do. Apologies that I don't have the current map with the bigger additional reserves, as well as I know it makes the boundaries poke out in a few places. You all know this area very well. Some dramatic coastline at the park, at the islands. Towering kelp forests. The California state fish, right? For those of you that didn't know that, the Garibaldi is California state marine fish. Abalone, of course. Those of you that know me know I'm an abalone lover from way back. But also these huge aggregations of pinnipeds out at San Miguel Island are an important part of this, and as well as the Native American cultural history here in the Santa Barbara Channel and at the islands. So that's some of the basic tour, if you will, of sanctuaries on the West Coast. I wanted to give that so you have a better frame of reference beyond just Channel Islands. But to jump to sort of the main heart of this, I'm going to give you here now some of the basic broad facts about climate change. This group called the Intergovernmental Panel on Climate Change is comprised of, I don't know, I think 30 or 40 scientists from around the world. I think this is the group that got the Nobel Prize for working on this particular issue. And some of the things that they've agreed upon based on the facts include how the global average surface temperature has risen. These are compared to a mean between 1961 and 1990, so about a 30-year period. And you can see what that's done. So values below the mean simply mean that over the last 150 years, it was below the mean. This is that 30-year period in here. So you can see that we're rising rapidly above the mean. And I heard even on the radio today there's a new scientific assessment that is acknowledging the temperatures are going to get even hotter, in particular here in California. Global average sea level in that same period has risen considerably. You can see the trend is upward. And then the northern hemisphere snow cover, which is an important thing, especially here in California where we derive so much of our drinking water from the snowpack, you can see that while that was somewhat steady for 100 years, it's been in a precipitous decline. I guess that's a pun, I didn't mean that, but a decline for 50 years now in terms of the snowpack. So those are changes that have been observed on the broad scale. Some of the other factors then, in terms of what's causing it, obviously you all know this well, so I'm not going to spend a lot of time on it, but some of these graphs show you the changes in greenhouse gases that are in large part from a human perspective leading to the toll on the climate. Carbon dioxide, again, these are over the last 10,000 years. You can see there's a slow and steady climb, and then it roars upward with the advent of industrialization. This shows that same area on an inset. This is methane, right? It was declining and then it soared upward, again during the industrial phase, and then nitrous oxide as well. So you can see these are all going up. These are the greenhouse gases and what they do to heat up the climate and change the planet is a considerable problem. This puts all those together from one station out in Hawaii, Mauna Loa, where you can see atmospheric CO2, the partial CO2, so that which is dissolving in the ocean also is going up, and acidity of the ocean is going down. I'm going to talk a little bit more about that. That's, if you think of sort of the three main problems with climate change are rising temperatures, rising sea level, and declining acidity, the pH of the ocean, meaning the ocean is becoming more acidic. So a declining pH. And that's been the more recently uncovered problem with climate change has been acidity and an acidic ocean and what that means. And I'll talk a little bit more about that. Each of these have their other linkages, greater storms, more rainfall, less rainfall, etc. But they're all broadly linked to those three major problems. And really all of those are going to be felt most in the ocean, right? Acidity is not really a problem on land, and rising sea levels only a problem if you live right along the coast. And so that's why ocean agencies, including mine, NOAA, are very involved in climate change and what does it mean. Here's a little bit on ocean acidification, and I probably have forgotten way more than I can remember in terms of what the cycle is, but it's somewhat straightforward. As you have CO2 in the atmosphere, it dissolves naturally into the ocean. Okay? The reaction, when it combines with seawater, creates bicarbonate, but also a hydrogen atom, a hydrogen molecule. This positive molecule then will strip away CO3 from carbonate, from calcium carbonate. Animals that form a shell form it based on calcium carbonate. And so the hydrogen atom can pull that away. Now you've got two molecules of bicarbonate, which is the acid in the ocean that makes the ocean more acidic, and you're peeling away the shell that shelled organisms rely upon. That's the basic problem with ocean acidification that you need to recognize. And some modeled results, mind you, these are modeled, include at sort of standard CO2 level of 280 parts per million CO2. The carbonate is 268 and the pH is 8.15. You can think of that as sort of standard ocean pH. Okay? You double the CO2 to 560 parts per million. The overall broad ocean scale prediction is pH drops to 7.91. You triple the amount of CO2 to 840 parts per million. The ocean acidity drops to 7.76. So that's really high levels of CO2 create this kind of a change. So remember that number because I'm going to come back to it. 7.76 is the modeled and estimated pH when you get to that level of CO2 in the atmosphere. And there's other problems. Some of you may be up on this. One of the bigger issues is that down the road, CO2 can get buried into the system. And when you get upwelling waters, you're bringing up deeper water which can hold more CO2 in it. Deeper, colder water, and you can actually create one of these biofeedback loops through upwelling in the ocean. Here's some specifics about what these might mean. This, especially acidification, might mean. There have been mostly lab studies. I think a few of these studies were done with in the marine system, but mostly they're laboratory studies. And you can see it's not always in one direction, but the physiological processes that are affected, largely focusing on calcification. Studies have been done with coccolithophores, planktonic forams, mollusks, echinoderms, tropical algae, and coralline red algae, right? And so you can see this line shows a decline. So this is bad for the animal. That's good for the animal. This one's neutral, and then this is sort of a bimodal effect. And so for coccolithophores, and these are a really important part of the very base of the food chain. Some say when these go, we're all toast, but two of them went down, some went up though. The rest of these all showed a negative response to rising pH and rising water temperature and CO2. Though not surprising, photosynthesis, right? The basic of photosynthesis is you start with CO2, warmer water, more sunlight, CO2, you create oxygen. So those photosynthesizing organisms actually did better. They showed a positive response or a neutral one, as well as for cyanobacteria. They went up as well. But in terms of animals' reproductive ability, mollusks, 4 species of mollusks and an echinoderm showed a negative response to increasing pH. So these are, again, some laboratory projects that have been done, but there's no real reason you'd think it'd be different in the lab than out in the ocean. Maybe not quite as pronounced, but nonetheless, the problem is, to all scientists that work on this, a real problem. So what is NOAA doing? What is Sanctuaries doing about this? Those are some of the basic facts behind climate change. And I want to talk about some of the things that are going on here, and I'll touch in detail on each of these points. To begin with, NOAA, as part of a new administration, and those that have ever worked for government agencies know that reorganizations are sort of a favorite step. But one of the things that the Obama administration did, and the new director for NOAA, Dr. Jane Lubchenco, was to create a climate service. And I don't believe this is one of those, let's just reorganize because we should. The goal of this is to create a team of people within NOAA that are focused on climate. They're pulling scientists predominantly, but some education staff and some other policy people from all the various units within NOAA to create this new entity. Most of them have come from OAR, the Office of Ocean Atmospheric Research. But the focus is to use research, observations, modeling, to make predictions as well as do assessments to provide science to government agencies, including our own, various services and various products. This was just approved in February 2010, so they're still what we call standing up this agency. But it's an important part of how we corporately within NOAA are trying to tackle climate change. And you can go to the NOAA website, and I think it's climate.noaa.gov, though maybe noaa.climate.gov. But you can get quite a bit of information. It's really a remarkable web offering that they have there on climate change. And our hope is that it's going to help really transform the agency in terms of how we go about focusing on climate change. I should say that NASA is also an agency with a great deal of responsibility over climate change, as well as the Department of Energy is working pretty heavily on this issue. And others as well, but those are the predominant ones. So for West Coast Sanctuaries specifically, one of the things that we have done is a year and a half ago we invested a little bit of money in producing what is called the Climate Change Impact Report. And we did it one site. Our hope is we're going to do it for all 14 of the sanctuaries, but we did it for one area, for 2 sanctuaries, Cordell Bank and Gulf of the Farallones, so just north of here. And it was a process that brought together about 40 scientists from around the region, from diverse interests. Some obviously physical oceanographers, marine geochemists, some marine biologists, ecologists, as well as coastal scientists and educators, to reach a consensus, if you will, on what will climate change mean specifically for that marine protected area. One of the things that we've observed, and maybe many of you have observed it too, is these predictions. I didn't give you any of the broad climate change predictions, can be these huge ranges that internationally the scientists are comfortable with, that sea level will rise between 30 centimeters and 3.5 meters. That's a huge range. That over the next 100 years, ocean temperatures will rise between 1 and 3 degrees. Now, those are big ranges. They have to do that, but we've wanted to know what specifically is going to happen at these sanctuaries. What's going to happen in terms of these physical features, but what will happen to the marine organisms that are there too. So this group of scientists, and it was sort of a culture shift for them where they really would prefer to give us these ranges and identify sort of variables and variances. We really tried to nail them down. And so this has some of the actual observed. I put some of them in there from this report. This report was just published in June of 2010. So sea level will rise. We know that. Well, how much? So what's been observed, this is an observed number, 20.1 centimeters, so almost 10 inches of sea level rise in 100 years at the tide gauge station that's at the mouth of San Francisco. So that's going to go up more. They give predictions for what it's going to go up to as well as maps that show us habitat inundation. But this is a real number that's gone on already, and it's just going to increase. I think over the next 40 years, that's pegged to double again at the mouth of San Francisco Bay. Extreme weather events are going to go up. And again, I'm giving the very summary of what this specific report provided, wind, waves, and storm, but that will lead to loss of different amounts of coastline. And it depends on what kind of coastline. Obviously, a rocky coastline won't erode the same way sand dunes will. But this group mapped the coastal areas in Mendocino, Sonoma, Marin, and San Mateo counties, and gave us predictions of areas by beach. And these are pretty stout predictions. These aren't just sort of wild-ass guesses, but it includes up to a loss of 50 square kilometers of coastline. And in some areas, we might only lose 20 meters of coast, but others, in these sandy dune areas, they're able to, with quite a bit of confidence, map 400 meters of lost sand dunes over the next 50 years. Saltwater intrusion into groundwater aquifers is going to take place as the sea level rises and as more groundwater is withdrawn. Obviously, threats to infrastructure. Piers that had 20 feet of clearance might only have 10 feet of clearance. And that might still be okay for most ships, but remember that winter storms can roll in, large waves, and instead of a storm every 10 years that might wash over the top, that might be an annual event. And there are other problems: seawalls, roads, sewer systems that require gravity feed. If the flow no longer can reach gravity flow, the seawater is higher than the intake point, you got problems. Increases to surface ocean temperatures. I didn't put the numbers in here, but I believe it was 3 degrees. 1.3 degrees over the next, by 2100, so in about 90 years. Those seem small, but those really mean a hell of a lot to organisms that are in the ocean. Considerably stronger upwelling and stronger winds, which is contrary to what we've seen so far. There have been some decreased upwelling winds, but the thought is there'll be stronger upwelling winds. The hotter the Central California plains get, the more air that's drawn in through the bay, and that's part of where that upwelling mechanism takes place up in that area. And then they have already observed ocean acidity hitting a peak, so a low, of 7.75. Remember that one number from before was 7.76 were modeled numbers when you triple the amount of CO2 in the atmosphere. That's broadly ocean basin wide. We've already seen and have measurements at the Farallone Islands of 7.75 pH. It then went up after that, but this is very concerning in terms of the amount of change. So these were specific modeled results that we wanted to get and measured results for those two sanctuaries. Those can then be translated into biological effects, right? What do you expect to see in terms of the marine organisms? So the main, responses to these marine organisms include remaining in the area and adapting. Some of this might require incredibly rapid adaptation. Animals may persist with significant costs. Another thing that could happen is they might move to better areas. And then fourth, they may adjust timing of life history characteristics that were in one way or another influenced. It doesn't include number 5, which is they die, right? They go extinct or they're extirpated from that area. But this is how the animals may adapt through various ways, dealing with metabolic rates, planktonic transport, what might be the availability of prey, etc. So what they were able to predict for us, and some of these things, again, have already been observed, but gray whales will be calving further north. They won't go, and they already aren't going all the way to Scammons Lagoon in Mexico. And they may be feeding on their way up because of food problems that they incur up in the Arctic. They're not able to feed, come all the way down and go all the way back before feeding again. And we're starting to see some of that behavior which hadn't been reported in the past. Low krill abundance, late breeding season by seabirds, that's already been observed. We lost an entire age class of Cassin's auklets at the Farallone Islands. Increases in dinoflagellate and jelly blooms. Decreased survival of Chinook salmon. And again, that's already been seen to a degree. And while it's not a big fishery anymore down here, it's a huge issue in northern and central California as well as Oregon. As well as contraction of stellar sea lion populations to Oregon. They're a very important species, a dominant species in some parts of the Farallone Islands, and they will move north. And this is relevant to a degree, and I know our colleagues in the Park Service have dealt with this, and I'll sort of point something out somewhat humorously, but it's a real issue. Glacier National Park exists because the glacier is there in that national park. When that glacier ultimately melts and goes away, is it the park that formerly had a glacier national park? Is it, the new rocky exposed area in the Glacier National Park? And the same could be true for Joshua Tree National Monument. If all the Joshua trees move north as predicted, what becomes of that park? We have similar problems with a sanctuary like the Gulf of the Farallones, which is there because of the seabird colonies and the pinniped colonies. We're unlikely, as is the Park Service, in dissolving the park or the protected area because these animals move away. Something else may well come there, and that becomes part of what we would be interpreting for the public. But we also want to be prepared, as I mentioned, if we know where the sea lions are going to go in Oregon, or once they finally get there, should we be there protecting their populations as well? And these are some of the big picture management challenges that we face and that we're trying to, with this kind of a document, get our arms around from a region-wide standpoint. And again, I know the Park Service is doing the same thing. Recommendations. We need to educate society better. We need to put ecosystems into context. The ecosystems matter too. It's not just that the planet will get warmer. What does that mean to the ecosystems? Anticipate change, as I mentioned. Right? If we know where the seabird colonies will move to or the stellar sea lion rookeries will move to, should we be protecting those areas now? Mitigate impacts on the system, and I'll talk a bit more about that, as well as adapt ourselves to change. In particular, that can include the physical changes that need to happen, seawalls and rebuilt harbors and marinas and roads, etc. So these are some broad recommendations, and they're not a whole lot more specific than this, and that's now the effort we're embarking on for those two sanctuaries, is to really nail these in much more specificity. There's about an 80-person working group. Not 80 people are coming together regularly. They did once. They've now formed subcommittees that are working on each of these 5 issues, but it includes many of the scientists, but also a lot of the policy folks up in the San Francisco Bay Area are helping us really craft a specific detailed action plan, which should be done in the next year. So some other things that is going on. Many of you may be aware that the Conservation Working Group for the Channel Islands Sanctuary produced a remarkable report on ocean acidification. Very well researched, very well written, and very well received. It led to, it was shared with first the West Coast sanctuaries. All 5 of the West Coast advisory councils passed resolutions asking our program to deal with this on a region-wide basis, ocean acidification, and to organize our efforts regionally. But ultimately, all 14 of the advisory councils around the country adopted a resolution identifying ocean acidification as a major problem that our program needs to deal with. And we're embarking on various efforts to deal with that. But that plan, which was ultimately adopted by your advisory council here, had 4 main goals: research, monitor, educate, and lead. And some specifics on those. These are specific to the Channel Islands Sanctuary, mind you, right? So prioritize the organization of a baseline of physical and biological data relevant to understanding the local effects of ocean acidification. What are the species and what will be the effects? Systematically identify data gaps, build partnerships with researchers. So this, there's a set of recommendations in research, a similar set in monitoring, including tracking how these changes take place over time, what their effect has been, as well as learning how the sanctuary's acidification and CO2 sensitive species and their ecosystems are affected by these changes. In terms of educate, there's quite a bit that we can do through the existing education and outreach programs to increase awareness on ocean acidification and what does it mean to the public and the stakeholders and other agencies, but also to include the causes of ocean acidification and its effects on sanctuaries so that people can really understand the role they're playing in a more acidic ocean. And then lead, in the end, seize the opportunity to address acidification through our own leadership. That can include our own facilities. And the new building that's being built out at UC Santa Barbara is designed to be a LEED gold building. LEED is the environmental standards that the federal government has set up. They're very difficult to reach. They require that you identify how your building is sustainable, as well as through various management, planning, and coordination programs locally, regionally, nationally, etc. So this has been the specific programs here at the Channel Islands. And what we are doing here on the West Coast, based on those resolutions that I mentioned were passed by the advisory councils, we've taken those very seriously, and I've got staff that are working on specifically addressing regionally ocean acidification. There is a lot of work that's being done on this issue. It's a very rapidly growing field. NOAA is developing an ocean acidification plan. There are various sanctuary efforts that are underway. And there's existing program functions that are going on, including here at the site. So we're not trying on a regional basis to replicate those or to outdo them. Where those are done, we're fitting in within those. There's a niche there for us to be working on this issue regionally. And this task force has been at it since the spring. They should have a draft report by September. It includes representatives from all 5 of the West Coast sanctuaries as well as the advisory councils. Includes a research person, an education person, someone who focuses on resource protection, management, and operations. So we've created this diverse team that's helping provide some very specific guidance as to how you coordinate this issue regionally. It was, I teased the advisory councils, was a bit of a hot potato they threw to me because they know it's a regional issue, but they didn't have answers. And so we sort of held the hot potato for a while and realized we don't really know how to tackle this either. So we've got this team that's putting together a region-wide plan to deal with acidification, and that's going to include a number of really important recommendations for us. So another thing that's going on, and you've all been a part of this, as well stems from the basic belief, and again, these are difficult to test empirically in the ocean, but a basic belief that healthy, complete, intact marine ecosystems are more resilient to the problems that come from climate change than broken, fractured, weakened, or lessened marine systems. One of the best tools that are available today to ensure intact, functional marine ecosystems are marine protected areas. And so this network of marine protected areas that were installed around the Channel Islands are a very important tool that help contribute to an insurance policy, if you will, the best bet to protecting this area from the impacts of climate change. So we're spending a lot of time, not just here, but at other sanctuaries on the West Coast, ensuring that marine protected areas are effectively implemented. These are some basic facts about marine protected areas from studies around the world. A huge increase in biomass. Some of this is pretty obvious. If you don't kill them, they will grow and live and thrive. They will be more dense. The size will get bigger and the diversity will get bigger. And these are all important in terms of having a resilient ecosystem from the impacts of climate change. I don't have the numbers here. I probably should have brought those, but the Channel Islands has got some great data on what has been the impact from those, the positive impact from these reserves, and they're basically the same. I think the density numbers are lower. The biomass numbers are lower. The density numbers are a little bit higher, and size and diversity also have started moving upward. So these are why marine reserves have an impact. But for these marine protected areas, there's definitely a shared mission that we have in the sanctuary program with the state that's put these in place. Long-term conservation of these resources while sustaining coastal communities. We believe that these will have positive impacts and do have positive impacts on coastal communities in terms of fish that will be caught, as well as recreational opportunities. But those are very difficult to predict, and we haven't predicted those, but we believe they're going to and are taking place. So you can see this network includes the network around the Channel Islands, 12 state MPAs. These were augmented in 2007 with federal MPAs. In 2007, the state of California put in 29 new MPAs as part of the Marine Life Protection Act in the Central Coast. 23 of those are in Monterey Bay Sanctuary. And then just this year in June, 24 new MPAs went into effect in the North Central Coast as part of MLPA. 13 of those and all 6 special closures are in the Gulf of the Farallones. So you can see that we've got a very close relationship, an important relationship with these MPAs. Again, down at Channel Islands, all of the ones in the Channel Islands Sanctuary are in the Channel Islands Sanctuary. The Monterey Bay Sanctuary is here. You can see how that network spreads out and includes Monterey Bay Sanctuary and then the ones in the North Central Coast. And I know you're getting close here to the South Coast. The Channel Islands network won't change, but you can see our nexus is very strong with these, and we want to see these networks succeed. So we are investing we've invested $2.2 million so far in the implementation at the Channel Islands, $1.4 million at Monterey Bay, and now that the North Central Coast network is in, there'll be a similar level of investment from Gulf of the Farallones. That level of effort includes research and monitoring, some work to help with compliance, but a considerable amount of education and outreach that the sanctuaries, frankly, are doing the work, and the state is a willing partner in that regard. They are the lead on compliance. We don't really do that. That's the state's role, and we share in research and monitoring. So some of those things that are being done in terms of education and outreach include producing new brochures, signage, websites, some of our multicultural programs, as well as, I guess this is a traveling exhibit here. This poor person got to dress up with that costume. But research and monitoring includes helping with a lot of the work that's being done in the nearshore areas, as well as doing the socioeconomic work that's identifying the benefit of these MPAs, and it's been considerable, as well as some mapping, water quality, and oceanographic monitoring. And then I mentioned some compliance enforcement. We've got various assets. The Shearwater here, the sister ship to the Shearwater is the Fulmar that operates out of Monterey for the 3 Central Coast sanctuaries. An aircraft. We've developed patrol guides that the state uses, as well as the Coast Guard when they go out on patrol. The National Park Service uses those as well. We've done these jointly with the Park Service, the Department of Fish and Game, and NOAA, working as a collaborative team to ensure that these resources are protected through these marine protected areas themselves. So another really important program was kicked off this year. And the basic view is that an acidic ocean will have the biggest impact in areas where you're at the margin of being able to lay down a shell. And that is thought to be the deep sea is the bigger problem. A lot of people talk about impacts on coral reef ecosystems, excuse me, tropical reefs, and they will have an impact, but it's going to be seen first in deeper water and deep water corals. NOAA began a program this year, a 3-year program, with a West Coast-wide cruise to identify and begin the basic monitoring steps for deep water coral habitats coast-wide. It began off Washington. It just finished up down here at the Channel Islands Sanctuary. It's a partnership with Sanctuaries and NOAA Fisheries, as well as some other NOAA offices, some folks in academia, as well as Native American tribes up in the Olympic Peninsula are part of this, and various research institutes. And there's various tools that we're using. Remotely operated vehicles, some autonomous underwater vehicles, right? So ROVs and AUVs, as well as manned submersibles, though that one may be not happening this year. There's some problem with the manned submersible, the Delta that is normally used. But the project began with some work, or the attempt at some work off the Washington coast. These are some essential fish habitat areas that have been designated in Olympic Coast Sanctuary, and some of the planned dive areas for those that have been involved in large-scale field research projects like this. When you're gone, this is a 40-day project. What can happen is the first part of the cruise goes well, and then things break, and those at the tail end lose out. This year it was the opposite, which can happen often. Bad weather off Washington coast, as well as the central coast, and some problems getting the sub really dialed in, affected the ability to do work. We had 6 days planned, and 1 real serious day was done up off the Olympic coast. 6 days planned, 1.5 were done off the central coast, but we nailed it down in the Channel Islands. Great weather. The ROV was up and operational. In fact, the only problem that the ROV crew had was that they were fearful that it was too flat. They were used to these wild, rolling seas. They thought they would get lackadaisical and wreck the ROV, bringing it aboard. But at nighttime, we did this AUV operation as well, right, where we were mapping in detail with this autonomous vehicle, the areas that we had just been to the day before, or we're going to the next day with the ROV. So the ROV gives you visual pictures. You can collect samples. The AUV autonomously maps the seafloor and tells you areas that you might expect to find corals in the future. So this was a multi-agency project, as I mentioned. It included doing some water chemistry that will help us. At the same time we're mapping and seeing, we're also sampling the water quality to know what's the acidity, what's the oxygen concentration, etc. So this is the first year, just finished up. We hope to, as long as the funding comes through, we'll be doing this again next year and the year after. And this gives us a great baseline for these species that are thought to be in some ways the canary in the acidic coal mine. So next up is to make the simple point that like this building here, right? The Park Service has definitely been far ahead of us for many years in the concept that visitors to a protected area need a place to go, a central place to go to learn about what is out there to go see and visit. That's especially important for a park like Channel Islands National Park, why this visitor center is so critical. We are just beginning to make investments over the last couple years and for the next 5 years in visitor centers, if you will, for national marine sanctuaries. It is very difficult. Many of you I know are part of the Naturalist Corps. You're interpreting for people who really didn't have much of a sense of what's out there in the sanctuary, and you're often in a boat, right, above it. You're not even down in it. And so these visitor centers are a phenomenal opportunity for us to talk about important issues like climate change. We intend to and will be using them for that. This is a building that we broke ground on Monday up in Santa Cruz that Monterey Bay Sanctuary is building. There's a big center in the Florida Keys, the Octos Center, the Education Center here at UC Santa Barbara will provide that opportunity when that is ultimately built over the next few years. We're putting in a center similar to this, 10,000 square feet at Gulf of the Farallones in 2-3 years. So these big centers, as well as the smaller visitor centers we have, are an important place where people are drawn to, and they want to come and see and understand what's going on in the sanctuary. And we intend to use our visitor centers as part of our educational tool to talk about and show people the impacts of climate change. And so I'm going to close out by talking about some of the things we'll be talking about in these visitor centers and some of the things that we get asked all the time, and many of you might be wondering, so this is great, it's interesting, somewhat gloomy. What can we do about it? What can I do about it? And I'm going to give you some pretty broad scale stuff, but these are things that you may have heard about before, and I'm just here to tell you them again. The way we're going to address climate change is we got to get the greenhouse gas emissions out of the system. We got to stop emitting them. Over time, they will naturally go down. By over time, I'm talking about centuries. But what that's going to mean is lifestyle changes for all of us. And that includes what you do as well as what you purchase. And what you purchase in particular can be linked back to plastics, which require a great deal of energy to produce. Oil needs to be drilled out of the seafloor or on land, needs to be developed in order to make plastics. But it's not just about plastics, it's about how you move yourself about, how you warm your house, how you warm your business, what are the electronics you have, etc. So reducing these greenhouse gas emissions can happen best through conservation. That's the best way we're going to get greenhouse gas emission reduction in place. We need alternatives, though, to automobiles in terms of how we move around. It's, as I said, this is one of these things that's easy here to stand, but I came down, I live in Monterey, and I drove a car to get down here. If there was a train that would have got me down here, I'd have taken it. But there is a train that leaves out of Salinas. It takes about 8 hours to get down here. But so I actually could take it, right? But that's part of the lifestyle change. Am I willing to? And so far I'm not. I'm willing to tell you this. I'm not willing to do this myself, right? But the incentive isn't there yet for me to get in that train and ride down to Santa Barbara and have Channel Island staff drive me around. But we've got to get to that point. I have to get to that point. You all have to get to that point. And we need to be willing to invest in innovative technologies to support a reduction in greenhouse gas emissions. And again, some of those things include these transportation technologies that get talked about. Everyone loves the concept, but elected officials are scared to death of implementing, like light rail. Again, I drove down from Santa Barbara today. Now, you all probably make this drive. I lived in Santa Barbara for 20 years, so I made the drive a lot. The traffic sucks between Santa Barbara and Ventura. It seems to not get better, and yet there's a rail line there. Why there's not a light rail that connects Ventura to Santa Barbara, it befuddles me. But I can tell you, I know it's being studied, but I know the economics don't look good, and folks just don't want to go, elected official folks, and they're afraid that they'll have to pass some ballot measure and some bond measure, and someone's going to have to find the money, and it's not sustainable, no one's going to use it. And I'm here to say we're going to have to all get there. There's really not a choice. This is sort of a one-way street right now, and we've got to build at least a second or a third way on this street. And so that gets down to this point of demanding action at all levels. But I want to flag this local thing because, in the end, there's an absolute need for a national plan to deal with climate change. And the state of California is trying to do a lot on climate change, and they deserve credit for it. But in the end, the problems are going to happen locally. It's going to be the need to rebuild Ventura Harbor, to move this visitor center when climate change gets bad, to build a seawall, and seawalls are only of limited utility. To move the sewer system and the outfalls, etc. The problems are going to be manifested from an ocean coastal standpoint locally. Local fisheries are going to collapse. And so the need to see local change and local interest in change is really important. I think too much time gets spent, well, not too much time, a hell of a lot of time gets spent talking about national change, and that's real, but we've got to also be talking about change at a local level too. And then folks need to become advocates. All of you need to become an advocate in what you do. Probably many of you are already, so forgive me if it feels like it's sort of a preachy point, but we need to create many, many, many more advocates who want to see this kind of change, or we're not going to have the oceans that we're used to today, and we're not going to have a whole lot of things on land that we're used to today. So, kind of in closing, to give you some real specific things, it takes those broader points and really boils them down. You could change 5 light bulbs. You could change 3 light bulbs, but you could change 5 light bulbs. You can insulate your home. You can spread the word, solar panels, use public transportation. Buy a hybrid or electric vehicle is an interesting one. Only buy one when your current car is ready to rust and fall into the earth, right? If you got a new car and you go buy a new hybrid, you're not really helping the problem a whole lot because the amount of energy that goes into buying and building that new car. But anyway, it's an important point. Nonetheless, we're going to have to get to all of us involved to find the change that we all are going to have to see over time. So I think my sunset shot is some wildlife. So thank you all very much. I'm happy to take questions.
I am very concerned about plastics in the ocean, not because of the carbon fuels that it takes to make them, but actually because of the decimation of all the sea life.
Yeah.
NOAA doing anything about that at all? I'm more concerned with that than global warming.
Well, that's certainly a more immediate problem.
Global warming, but you
Yeah, and you could actually do something today or tomorrow about plastics. So I'm sympathetic to that viewpoint. The National Marine Sanctuaries, right, as part of NOAA, all sanctuaries are working on broad programs that are just loosely labeled marine debris programs. All sanctuaries, I know Channel Islands helps to promote and sponsor beach cleanups, which are necessary. But I don't think we are militant enough about sort of identifying for people, what's picked up. A lot of the folks that go are part of the choir that go clean up that beach. There needs to be more of a messaging back about look at all the stuff we're finding on the beach. Most of the stuff on the beach and most of the stuff in the ocean didn't come from the boat. It came from land. And so we do a lot of work in watersheds where we can afford the time. And NOAA corporately is trying to do a lot of work in watersheds on the need to reduce the flows, not just go out there and pick them up. And so I think we celebrate these great beach cleanups that we do. They're to be celebrated, but I don't think we've found the right way to not to get too negative in people's face, but we've got to make the simple point. This stuff's coming from land. You can pick it up before it even gets in the ocean. Ultimately, reducing the production of plastics is probably beyond what we're going to be able to do. Others are going to have to be pushing that. It's not something that I'm aware of that NOAA is pushing, that there need to be alternatives to plastic. But that's part of what I had said about what you purchase is really relevant. And last night I gave an example in Santa Barbara. Right before that presentation, I grabbed, someone from the staff grabbed for me some food at the restaurant right there. And it came wonderful food in a nice sturdy plastic box, right? And had I known that, I probably wouldn't have ordered it. I'd have gone and got it myself, but I'm off and I feel like I'm pretty good about that, but that one missed me. And so now I'm stuck feeling guilty eating this food that I'm going to put in a recycle bin. But most plastics really don't get recycled. They end up going to China, right? But they get burned for fuel, and some get recycled there, but not a whole lot. So I think we're all going to have to get a whole lot better at that, and that's the best way to reduce the amount of plastics.
I guess my point was that was a really interesting slide. Can you put that slide back up there?
Sure.
Because I got the message from that
This one here?
Yeah, most of that stuff there has to do with the use of carbon fuels and trying to reduce that. And I just want to make it clear that it's orders of magnitude, just breathing, exhaling of animals is orders of magnitude more than all the carbon used worldwide for burning. You can do those calculations, they're on the internet.
Yeah.
Are you aware of that?
Well, yeah, but I think the thing to remember, humans exhale a lot, right? And if you go back to that early slide, I won't go back because it's 25 slides ago, there have been a lot of humans and a lot of really big animals on this planet for a long time. And the CO2 never went up like it did once we started burning carbon-based products.
Well, the real problem is overpopulation. There's too many
Yeah,
animals,
there
but
are.
I don't want to check out our one yet.
Maybe we should have hold your breath.
Yeah.
I just read recently in some trusty science magazine about the krill making a big comeback in the Bay Area, and salmon getting a reprieve. And it's now, is that a true story? Is that happening? And if so, it's just a temporary reversal in the small.
Yeah, right. That's a great question. For those in the room, I'll just take it back 3 or 4 years. Salmon collapsed about 4 years ago. And, one of the big problems is water in California, how water gets used, and the construction of dams and the hatchery system. And in addition to that, really poor ocean conditions over those, 2005, 6, 7, or 6, 7, 8, led to a large die-off, is what scientists now believe, in the juveniles as they're coming out of the rivers. And 2 or 3 years later, they're not there to come back to the rivers to be caught and replenish the population. And so the thought is that actually those were really masked. Go back 5, 6 years from that, right? So 99, 2000, 2001, 2002, those were some exceptional years in terms of upwelling and ocean productivity. And so what we were seeing was really high years prior to that, 5, 6 year period, that the fishery managers were setting quotas on, based on the assumption that, I think the numbers are like 800,000 adult Chinook king salmon returning to the Sacramento River. When the real number was probably, on average, around 200,000. We had those bad years, those dropped to like 30 or 40,000. And now it's gone up. So now it is a good year, this year, which is good for Chinook smolts as they leave the river, and in 3 years when they come back, it should be a decent fishery based on that. But I don't think anyone really has it down in terms of what's going to be happening to the system. The scientists working for us gave us the prediction that it should be better for upwelling. Krill should be better, and that should be, all in all, better for salmon. But the reason they said salmon might do worse has to do with the amount of flows, snowfall in the Sierras that lead to water into the reservoirs and the dams coming down. So that's thought to go down. We're going to get bigger peaks, higher rainfall and snowfall, but melting of the snowpack quicker, and that will have a bigger impact on the salmon going forward than healthy ocean conditions. You need all of those elements for it to be good for salmon. And the dams and the hatcheries in particular create problems because you're picking from a smaller and smaller genetic group year after year after year that come back to that river. And so 100 fish, it's not that, but 1,000 fish might be used to repopulate an entire stream that in the past would have had 20 or 30,000 fish. So those problems all compound. But it is thought to be a good year this year for young salmon, and that's good. We expect that upwelling will be better than what we have typically seen if you average it over a 30, 40-year period. So what that ultimately means to salmon, though, is linked to, well, compared to what? Compared to 100 years ago, 3 years ago, 30 years ago, 6 years ago. It should be better. They should have a fishery, but it's probably not going to get back to 800,000 salmon in the river, which was 10 years ago what they had.
Another question.
We'll go right behind you then.
I know that California and NOAA funds a lot of research through the California Energy Commission in terms of coastal and ocean resources. Is there any activity that you know about that specifically targets this particular region for research? Because if you work for an organization and you're trying to move a public policy and you don't have science behind you, it's very hard to make public policy. So I think what's really important, I mean, you mentioned a few things like seawalls and we talked about the harbor. You didn't mention retreat, but public policy issues, all of those things are a part of the equation, but it's all predicated on science.
There are two things that I'd respond to you with. One, I know the state of California has formed within the government agencies working on coastal issues a climate change team that's focused on that. And they're trying to do some research. The Ocean Protection Council is funding a little bit, but not a lot. In Sanctuaries, we are just so tight in terms of dollars, we're not funding much research of any kind, though we'd like to. There is money that's gone into the National Science Foundation to fund climate change research. Many of that's going to big university projects, not really small, locally oriented projects, which is part of why I'm flagging local needs to become part of the focus. So that's sort of one category of the government agency funding, but I do know that, I don't know the specifics of it yet because I don't think it's been announced, but Packard Foundation, the Moore Foundation, the Goldman Fund, a lot of these California West Coast nonprofits that fund these kinds of programs have pooled their resources to come up with sort of a consolidated funding strategy for climate change. Because they don't want to either be funding the same thing or having bidders, conflicting and competing with each other for their program. So I know they've pooled their resources and they've been, sharing staff to come up with an integrated plan, and it's soon to be announced. But that will probably be far more likely to help influence, these kind of, smaller scale, lower level, from a federal hierarchy, funding programs that might include NGOs and local governments, and other, local-based initiatives. Will have a better shot, in my view. I'm predicting, of course, I don't know for sure, but based on what they've done in the past with the Goldman, Pew, Packard, Moore Foundation team. And I'd look for that, and that'd be something that you can probably go to any one of their websites. I know Moore and Packard would be the ones I'd aim for, and see what do they say about funding climate change. You have another question?
I just wanted to know, is the acidity issue in the ocean, is it stratified? Does it change? Does it just, I think you said CO2 can sink?
Yeah, well, it dissolves,
It
right?
dissolves,
And
but
yeah.
is it more acidic versus surface where the first reaction happens, or is it?
The bigger problem is down deeper.
So you said deep sea coral.
Yeah, and deep sea corals. And so this is where I'm going to stretch my scientific recollection on this, but it has to do with sort of the partial pressures in the dissolved bicarbonate and the effect that it can have. But what the scientists have seen are these plumes of acidic water, so lower pH, coming up from down deep and coming up onto the continental shelf. And some of this is that there's less mixing in that area, right? And so what I mentioned before, too, about part of the problem is that there's talk about these feedback loops in climate change, right? If the Greenland ice shelf melts, we'll have a feedback that hasn't really been modeled well. And the permafrost in Canada and Alaska, as that thaws, that will have a feedback loop by releasing methane and other carbon. It's also thought that these upwelling of older water that might have even more CO2 in it, or accumulated CO2, can have a problem. So we could get CO2 out of the atmosphere, reduce it down, but in 50 years, that's about how long it takes on average for water to move through an upwelled system. Water that's 50 years old is now down at the bottom that would come up off Point Conception in a future upwelling event. And so you could get CO2 levels down, but still have acidic water and CO2 released from upwelled water in the future. And so it has to do with sort of how the cold water itself can store more CO2 in it and how the pH can rise. But it also affects organisms in those areas that are closer to the margin of being able to actually lay down a shell in the first place. So those animals that are living at the margin will be affected, which is why smaller organisms will be affected at the same pH sooner than big organisms. The smaller organisms are forming, it's a smaller chemical reaction. It's not happening across the shell of a lobster. It's happening at the shell of a tiny organism that's 50 molecules, 50 cells wide as it's beginning to form its first shell in the ocean. And so they'll be affected more, and they're the base of the food chain too, which is why you won't see lobsters without shells. You're going to see nothing in the ocean is what will happen first. And that's the bridge. Yeah.
This is sort of the same question, but a little different. That was sort of the vertical concentrations. I'm thinking of horizontal concentrations. I mean, the CO2 is in the atmosphere, so I'm guessing it's falling on the ocean consistently around the world. But in other words, is ocean acidification a bigger problem off the coast of Los Angeles than it is in the Marquesas?
Yeah, so I don't know for sure that. I know in coastal systems, as opposed to open ocean systems, it's a bigger problem. And that, again, has to do with upwelling, where you're constantly moving, so you don't ever really purge the water out of the system. Once you end up with water out in the middle of the Pacific, there's 30,000 feet or 20,000 feet of water mass to move around versus the coastal water, which might be 1,000 feet of water. But I don't know about the coastal Marquesas, or Tahiti. Is that coastal water the same as coastal water off California or China? That's a good question. I don't really know precisely the answer to that. I think there are people I know there are people working on it, trying to measure it globally, and that's where this broad global ocean observing system is paying some dividends to try to measure that. But not all buoys are monitoring for acidity, so they're trying to work on proxies where you can estimate water temperature and oxygen and know with a great deal of certainty what the acidity is. And so there's some work that NOAA is doing on that very problem to find easier ways of developing proxies so you can quickly monitor the oceans broadly and have a pretty good sense of what the pH is. Yeah.
Can you talk a little bit more about, as you continue to develop more information about kind of the anticipated impacts of climate change on the sanctuaries, what will be kind of the next step?
What do we do about it?
Yeah.
That's the $64,000 question, and I appreciate that. We want to get to that point. I don't think we're there yet. We're there in concepts, but we're not there in terms of specifics. And I'll give you an example because it's kind of easier to understand. At least options that are available to terrestrial protected area managers are that maybe there's a species of tree that does well in Mexico where it's warmer and drier rather than the southern Sierras. And so maybe a manager would be willing to transplant that species up in order to keep it in the protected area. Right? There's transplantations like that are much more challenging in the ocean if they're ever even done at all. So those kind of deliberate manipulations of the biome are possible, not always being done on land, but they're very, very difficult in the ocean. So that's a tool we don't have in our tool chest. We can do things like push for marine protected areas, right? Because they help, and not they alone, but other things can help produce the most intact and thus likely most resilient ecosystems. So we are pushing on those kind of broad protections. We are evaluating, but we're just beginning, this notion that I mentioned about where are the species going to go? And if we know they're going to go to an area, should we begin protection initiatives now? Even if we don't know they're going to go there, should we be working on initiatives that help provide that? And that could include things like the Arctic, right, where it might soon be open. The view is it's not long away, 10, maybe 20 years before the Arctic is ice-free in the summer. Access will now be significantly easier into the Arctic. Should we be protecting areas right now as national marine sanctuaries or national parks or national monuments before the demands and the options are there to exploit those? And to their credit, what's called the North Pacific Fishery Management Council in Alaska has already put some of those areas off limits to bottom trawling. So people are working on those things, and those are kind of things that we get to. But it is, it's a tool chest. We don't know how big it is. We don't know what's in it. We don't know how well the tools work yet. And that's what we want to get to. And I think that's like 10 years worth of work. That's not something we will quickly get to. That will require some some tough policy choices. Yeah.
Since the seaweed forest, kelp is, I guess, as important as land forest in replenishing oxygen. Is there a study going right now in terms of ocean temperature and the effect on what's going to happen to our kelp forest?
Well, the thought there would be, you got on the west coast, I'll just give you the west coast, you got these two big brown algae, right? Macrocystis and Nereocystis. And Nereocystis you tend to find further north. That's the one that, is bullwhip kelp, forms a bulb that floats up with a big long tail, with bulbs at the top and tails at the bottom. Macrocystis, obviously you know that, many branches. The Macrocystis is more common in warmer water. So the thought is that Macrocystis will move further north. And Nereocystis will move further north, but it'll be replaced by Macrocystis. In terms of acidity, whether acidity will affect it, I don't know the answer to that. I don't know if there's been studies done on that or if there is what those studies show. But that's the basic thought, is we get more Macrocystis. At a certain point, it'll be lost in the southern range too, right, where the water's too warm. Yeah.
I guess there's evidence on the Channel Islands that climate change has been occurring for millions of years, from glacial periods to interglacial periods, and that the Earth was warmer and the sea levels were higher in past interglacial periods than they are now. Is it possible to kind of say, in this current interglacial period, how it compares to the past?
Yeah, so that's been one of these issues that's always troubled me too. So what is different between now and then? And as it's been explained to me, that and I trust this now, the problem is the rate of change. It's changing so rapidly, organisms can't adapt to it. That's the biggest ecological problem. The secondary problem, maybe it's a bigger problem, is from a sort of a human social standpoint. Everything that our systems and our way of life is built around sort of assumes a climate pattern that we've seen for the last 100 years. It's going to be really hard on humans as climate change progresses. And that's, as real as anything else, on businesses, on ways of life, in terms of what the climate is that you're used to, what crops will grow, is there water for your lawn or your car or your produce? All that is likely to be changing, and very rapidly. And humans, by and large, there's some, obviously there were humans around when the glaciers formed and retreated. But the rate of change that we're going to be seeing has never been seen before. So that's going to be the big problem for us and for organisms. And so there can be some examples learned from that about what the endpoints look like, but the geologic record doesn't track the change points, how fast, what's happening as it's changing, as the glaciers retreat, can you see it, or is it over a lifetime the glacier moved a little bit, right? And that's, in some ways the problem with geologic records, is they're incomplete and they're long. Any other questions? Yeah, sure.
These areas that you buoyed off, I guess, not even allowing any ships in?
Yeah, no fishing areas?
Well, not only, but I thought you had.
Oh, yes, there are 6 there are 6 very small areas.
What made you set those aside?
Yeah, so those were set aside because at the Farallone Islands, but not just there are some remarkable seabird colonies in that area. And at certain times of the year, they are easily disturbed by vessels, not just fishing boats, any vessels, any humans. And so the state of California, in some ways on an experimental basis, and it's not designed as an experiment per se, they don't go away after a certain point, agreed to 6 closures, and they're very close to shore, like 100 feet or 100 meters from these specific areas where seabirds, and I think in 2 occasions where pinnipeds are very common and abundant. They could be done in other places too. You could obviously do them in certain places at the Channel Islands.
You have it in place in Santa Island.
That's right, there is that one.
And Santa Barbara Island, to stay offshore like 100 yards.
Yeah, it's 100, I think it's 100 yards, that's
Bill,
right.
what is it?
What's that?
It's Anacapa Island Pelican no-go zone?
Reserve.
Yeah, that's it's a quarter mile from the,
Quarter
yeah.
And is that year-round or is that seasonal?
That is,
Seasonal.
It's seasonal, that's what I thought.
Like March.
So
These are
there's a small window, is there just in the late fall?
Well, it's October. Right. So it's open from October to December. The rest of the year is closed. It's during the pelican
Right.
breeding season
Right.
to protect the young who come down to them.
And those are common to, Fish and Wildlife Service has some of those in Oregon, where some of their big rock sea stacks are, again, because of bird breeding colonies. So, there haven't been, as a network, they haven't been used in California. They've been used in very discrete places where, over time, an uproar convinced the state to adopt them. Yeah.
Well, we've had few vocal naysayers in relation to climate change. You really don't have many questions from any scientist about the acidity problem, do you? Is there, that's pretty well accepted by
Yeah.
everybody, right?
I think some would still argue that, there really isn't climate change going on, or humans aren't the cause of it. But it's a pretty straightforward chemical reaction. Is kind of what's going on, and it's one of the ones that's easier to see, in terms of what's going on in the ocean. But it's in some ways a little more technical than the weather will get warmer. The ocean will get acidic. And what are you talking about, acidic? How? What? When? Where? I don't get it. And so, it may not have been attacked necessarily because it's somewhat trickier for many people who might otherwise disagree with it to understand it. But you're right, I haven't heard a lot of the same sort of naysaying as I have heard about the climate change as a whole. Yeah.
What do you like most about your job, and what would you change about that?
These are my students, they're forced to ask them.
You're forced to ask that? Good for them. So what I like most about my job is I was a sanctuary superintendent for 8.5 years. And I'm from Monterey Bay, so it's a pretty big area. But I like the ability to tackle these broader regional issues and, to work on them both with the 5 sanctuaries in the West Coast, but with other partners like Park Service and different state agencies, National Fisheries Service that are working on these big global problems, or in this case, large marine ecosystem problems. But now I'm going to tell you the opposite side of the coin, right? What I would change, what I miss most about being a sanctuary superintendent, are working on localized problems that you can walk out and see and touch and feel and relate to, tomorrow afternoon. So, if the Channel Islands park superintendent or sanctuary superintendent, they're the ones worried about those brown pelicans. And look, too many boats are flushing those birds. I got to solve that. How am I going to solve that? And so they get to work on that, which you can wrap your arms around. And the problem that I said, what I like are these big challenges, but there's something missing too, right? It moves slowly. You don't get quick closure on things. It's a lot of negotiating, which is a huge challenge, and I like the challenge. But there are many days when I want this little discrete, packageable,
Instant gratification.
Yeah. It's not instant, soon gratification. Gratification of any kind. Well, thanks all of you for coming. I really appreciate the opportunity.